Hello everyone, my name is Diego Andres Lopez. I'm a second year master's student in the group of Dr. Stein, and today I will talk about the standardized total track digestibility by growing peaks of phosphorus in feed phosphate from volcanic and non-volcanic sources. As an introduction, phosphorus is a mineral that has to be supplemented in most diets due to the low availability of phosphorus in plant ingredients. Therefore, we use feed phosphates, which have a high digestibility of phosphorus, and some of these are monocalcium phosphate, monosodium phosphate, and magnesium phosphate. The production process of these feed phosphates will start with phosphate rock, which can have two different sources, sedimentary or volcanic sources. In the case of sedimentary, what we can observe is that most concentration of phosphorus comes from francolites, whereas in volcanic, most of the concentration of phosphorus come from fluorapatites and hydroxyapatites. But sedimentary sources tend to have more impurities, such as carbonate, sodium, and magnesium, and this will decrease the concentration of phosphates, which could also decrease the concentration of phosphorus in the final product. After we obtain the phosphate rock, we will treat it with sulfuric acid to produce phosphoric acid, and this phosphoric acid will be used in a second reaction to produce the feed phosphate. In this case, I will show you that if you use calcium carbonate in a reaction with phosphoric acid, DCP and MCP will be produced. Therefore, having all this in mind, the objective of this experiment was to test the hypothesis that the digestibility of phosphorus in feed phosphates from volcanic sources will be higher than feed phosphate from non-volcanic sources. For this experiment, we used 40 pigs with an average body weight of 15.61 kilograms, and then we formulate a phosphorus-free diet to be able to measure the endogenous phosphorus losses from the pigs. And from this phosphorus-free diet, we include 4 of the different feed phosphates that were used in this experiment. 2 of them MCPs and 2 of them MSPs from 2 different sources, volcanic and non-volcanic. In these experiments, all pigs were allotted in the 5 diets, and then they were housed individually in metabolism crates where they have free access to water, and they were fed twice a day. In this experiment, we start with an adaptation period from day 1 to day 5, and then in day 5, an undigestible marker was fed to the pigs to start a collection on day 6. And this collection will go until day 10, where a second marker was fed, and then the pigs were kept being collected until they passed the second marker, which was approximately on day 12. For the nutrient concentration of the ingredients that we use, first I would like to set up my slide. Blue colors will represent MCP, orange color will represent MSP, and in this case, the darker color will represent the volcanic source, when the lighter color will represent the non-volcanic sources. First, for phosphorus, we observe that all these ingredients were in agreement with previous reported data. However, the concentration of phosphorus in non-volcanic MSP was higher than expected. In the case of calcium, the concentration of calcium of the 4 ingredients were in agreement with what we were expecting. Moving into the concentration of dry matter and ash, the results were also expected. And since these feed phosphates were produced by the wet process, the difference between dry matter and ash will be for the loss of carbonates and crystallized water. Now, moving into the results, first, from the standardized total track digestibility of phosphorus that from now on I will be referring as STTD, we observe no difference between volcanic and non-volcanic sources for both MCP and MSP. However, the volcanic source of MCP had a lower digestibility than both sources of MSP. Now, for the apparent total track digestibility of calcium, which I will refer as ATTD of calcium, we observe no difference between any of the 4 ingredients that we use. So, as a conclusion of this experiment, we observed that the STTD of phosphorus was not different between sources, And the only difference that we can observe is that monocalcium phosphate will tend to have a lower digestibility than monosodium phosphate, which will be the driving force of the results that you observe. And also, ATT of calcium was in agreement with previous reported data. With that, I would like to acknowledge Yara for the financial support of this research, and I would like to say thank you to the Hans Stein Monogastric Nutrition Laboratory for all the help to conduct this research. Thank you so much for listening to me. If you are interested in nutrition or in more about feed phosphate, please follow us on our social media or listen to our podcast.